Okay guys, today those of you who are going to retest a week from today, you are going to watch the video over the transformations test to see where you went wrong. Alright, so we're going to go ahead and begin with the very first one. Polygon LMPQR is dilated, and some of the things that I tell you guys to do is make sure when you know something is dilated, it's either reduce or enlarge. And they gave you the scale factor. Scale factor is 1/2. So if it's less than 1, reduce the figure. So then it says with the origin at the center of dilation to create polygon LMPQR all prime, select the location of Q only. So I'm going to go here and look for Q, and I'm always looking for my X first, then my Y. So on my X-axis, which is horizontal, is 6, and my Y-axis is 2. So the only thing you had to do, if you guys always say you can't show work, easy. I'm showing it right now. So then you will multiply the scale factor times 1/2, both X and Y. So then the new prime, 6 times 1/2 is 3. And then 2 times 1/2 is 1. So my final answer for Q prime for the new image was 3 and 1 was my answer. All right, so let's look at number 2. What are the important words? Similar, same, shape, different size. So each dimension of the field is 3.2 times the corresponding dimension of the playground. So which statement would be true? Normally when you're looking at the area, say you have a field this big and then you have a playground this big. So these would be similar figures, and we would look at area base times height. So that means that you take the 3.2, and then when you multiply that, you should get 10.24. Now, what we know about this, if we're looking at the area, what would be true? First of all, if you got 10.24, we can automatically get rid of the area for 6.4, and we can also get rid of the perimeter. So your best answer choice, because we are looking at the area, we have calculated it, and we know it's not perimeter. So your best option was B. Let's go ahead and look at number 3. I keep telling you guys it's all about showing the work. So if you have MNPQ and it's translated, so that means it's going to be a slide, 8 units left, so that is going to be my X-axis, and 4 units up, that is going to be my Y-axis. To create the new MNPQ prime, and then write the rule that describes the translation that is applied to quadrilateral MNPQ to create the new. So this is the old or original, and this is the new. So then if I am sliding, for my rule, I'm going to start with X and Y always. But if I'm sliding, we know that if we are sliding to the left, we're going to subtract. So that means on the x-axis, and then it's 8 units, that would be x minus 8. And if we are going to go up on the y-axis, that would be adding, and it's 4 units up, so that would be y plus 4. And I just wrote it. So now I can come down here and look at my elimination. So what can I eliminate? Anything that has y minus, I can get rid of that because I have a y plus 4. Okay? We're not multiplying. This is not a scale factor. This is immediate get rid of. I know that my x is a subtraction and it's not addition. I can get rid of that. So immediately I was able to get rid of certain things. I can get rid of C. That's multiplying. We're not multiplying. So the best answer choice was, this was x minus 8, which was A. And then this was y plus 4. I can get rid of this one too. And I did. E. So y plus 4. And since I already wrote it, that made it a lot easier. All right, let's go ahead and look at number 4. So quadrilateral, which is the OPQRS, is dilated. So anything that's dilated, we know we're going to either reduce or we are going to enlarge. So then, with the origin as the center of dilation to create quadrilateral PQRS prime, so then this is the new and the old. So the coordinates of each vertex are integers. Each side length of quadrilateral PQR is, well, what I'm going to do first, before I answer this, I'm going to choose a point. And I am going to choose, let's see, I'm going to take R, let me highlight it. So I'm going to take R prime and the original. So new over the old. So I'm going to go ahead and first write down R versus the R prime, X and Y. So my R is x-axis first, -2. So my X is -2. And then what is my Y? It is -6. So now I'm going to look at my prime. My X is -1. And here, -3 is my y-axis. So now all I have to do is, this is the new, and this is the old. So then, all I have to do is pick 2 points. Doesn't matter which 2. So then, whether I pick these 2 or these 2, it really doesn't matter. So I'm just going to go ahead and pick the y. My new is -3, and then my old is -6. When I simplify this, a negative divided by a negative gives you a positive. So if I am reducing this, -3 divided by -3 gives you 1, and -6 divided by -3 gives you 2. So it's 1/2. So when I come down here, look at my answer choices. This has never been given to you as a vocabulary word, so I would not have asked a teacher about this word because this was not one of your vocabulary words. Half, congruent, twice the corresponding side length. So then this was the key, that it was twice the corresponding side length. So that would be D. And one of the things that you already knew, or you should have known when studying, is that when you have angles on similar figures, they are always congruent. Always. The angles are always congruent, and the corresponding sides are not. So that answer was C. Real simple. Okay, let's go ahead and talk about number 5. A square with a perimeter of 20 units is graphed on a coordinate grid. The square is dilated. Well, if it's dilated, that means that it is a reduction or enlargement. Then it tells you the scale factor is 0.4. So the scale factor is 0.4. You should always get in the habit of rewriting things so that you can understand better, with the origin as a center of dilation. So it says if x, y, this is the original, represents the location of any point of the original square, which ordered pair represents the coordinate of the corresponding point on the resulting square. Well, they gave us a scale factor. This would be wrong because it's adding. This is more of a translation, and you had your cheat sheet. This is not the scale factor because they gave you 0.4, so that was out of the question. There was only one that would have been the correct answer, and that was B. Okay, so here we go with triangle PQR transformed by the rules that you had to create triangle PQR prime. That means this is the new. Check all of the boxes that are true about triangle PQR, which is the new. So when this is transformed, we're going to look at what's congruent versus if it preserved the orientation. Well, this says x plus 9 and y plus 4. We clearly know that is a translation or slide. All the figure did was either it's going to slide on the x, left or right, and slide on the y, up and down. Well, is it congruent? Absolutely. Didn't change the shape. Does it preserve the orientation? Absolutely. All it did was it went left, right, up, or down. So wherever that letter was, it stayed in the same position. Let's look at 90 degrees clockwise. That means if it's 90 degrees clockwise, one turn right. If this figure turned, that means that your x becomes y and your y becomes x. If that happened and it made a turn, the letter made a big difference. So the position is totally not preserved, so I'm not going to circle that one. But is it the same shape, same size? It is still congruent regardless. It just turned the figure. So then the only thing that it does not do, it does not preserve the figure